No?
No, she's 5 months old. So.
You just send her out.
Yeah. She would just roll around and cry. All right. 41 is negative 35 over 53, comma, negative 10 over 53. 42 is negative 435 over 106, comma, 783 over 106. 43, 85 over 106, negative 153 over 106. 44, 261 over 73, negative 696 over 73. 45 is about 34.94 pounds. 46 is about 61.56 pounds. 47 is about 116.92 pounds. 48 is about 95.22 pounds. 49 is about 117.48 pounds. And 50 is about 99.06 pounds. So let's go through and do some of these together, shall we? So, should we start here with 41 or whatever that is? That's the number, right? Is that okay with you guys? Okay. So what I'm going to need then is my formula, which is vector u dot vector v over the magnitude of vector v squared times vector v. Everybody okay there with just writing down the formula? So the first thing I'm going to do is the dot product of vector u and v. So I'll write down what my vectors u and v are. And then how do I do a dot product? I multiply the x components together and multiply the y components together and then add them up. So far, so good? The next part I'm going to do is the magnitude of vector v squared. So the magnitude is x squared plus y squared, square rooted. But since I have the magnitude squared, I have that extra squared there, which is going to cancel out my square root. So I'm just left with 49 plus 4, or 53. So I have here then negative 5 over 53 times the vector 7, 2. So this is scalar multiplication. So negative 5 times 7 is negative 35. And then negative 2 or negative 5 times 2 is negative 10. Okay. Now, reasonable expectation, I think, that you're able to perform one of these computations, right? That shouldn't be too terribly time-consuming, and nothing outrageously complicated about that computation, right? We're basically just doing some addition and subtraction, multiplication and stuff. You just have to know how the operations work, but I'll give you that stuff on the formula sheet, so you don't even have to memorize those things. Caitlin? So vector v is 7, 2. It was because I was doing the projection onto v. Okay with that? Should we do another one of those first 4? Sure. Do you have a preference on which one to do, Caitlin? Since you're the one that said sure. 4. Okay. Okay. So the first thing I'm going to do is start by writing down my formula. And then, just like before, I'm going to start by computing the dot product. Need what W is, 5, negative 9. And I need what U was, that was negative 3, 8. So just like before, to compute my dot product, I'm going to do the product of the x's plus the product of the y's. So it's negative 15 plus a negative 72. That gives me negative 87. Everybody okay there? Yuck. Then I'm going to do the magnitude of u squared. It's going to be x squared plus y squared, all square rooted. But I also have the magnitude squared. So just like before, the squared is going to cancel the square root. So I'm left with, oops, not that. 8 squared is 64. So that gives me 73. So I have negative 87 over 73. Then times the vector u. Okay, there. And now I need my calculator for this piece. I can't. It's too early and too much like a Monday to do 87 times 3 in my head. So that's 261 over 73. And then 8 times 87 is negative 696 over 73. Does that feel okay? All right. So let's do some of these vector problems. Should we just start with the first one? Do you have a question here, guys?
Oh, I was just asking.
Up here? You can just raise your hand and ask. It's not a big deal. There's only like...
I just figured maybe you had it down.
Oh. Yeah, there's only 10 of us in here. It's not a big deal. We can scroll up and down. You know? I'm just want to be helpful. You know what I mean? Okay. So this first problem says Jenny is sledding down a hill with an angle of 15 degree, or with a 15 degree angle of incline. if Jenny and the sled weigh a total of 135 pounds, what amount of force is sliding down the hill? Okay. So here, do we know anything about this hill other than its angle? It's going down, right? But do we know anything? Can we say anything about the magnitude there for that? No. So I'm going to just set the magnitude to be 1 then. Since we don't know anything about the hill's magnitude, I can set it to be whatever I want, and I will pick it to be 1 because it just makes everything quite a bit easier. Okay. So I'm going to draw myself a picture then. So here's an XY axis. And here's going to be my hill. So when we say angle of incline, we're really talking about that angle there being 15 degrees. Okay with that? Now, because of the alternate interior angles theorem from geometry, that means that that angle is also going to be 15 degrees, right? Somebody, alternate interior angles. So that dashed green line that I drew and the x-axis, those lines are parallel, and parallel lines cut by a transversal, those alternate interior angles theorems apply. Is that okay? You kind of vaguely remember that then, Giselle? Okay. So to get the direction then, I'm interested in that angle there. Everybody's good with that? I'm going to call that angle theta. So 90 from the first quadrant, 90 from the second quadrant, 90 from the third quadrant, and then how many from this last quadrant? Yeah, 75, which is 90 minus the 15. So that's going to be 345. If you thought about this as 360 minus 15, that would be okay too. So what I'm going to do then is I'm going to resolve this vector for my sledder. So their magnitude is 135, and the direction is 345. So I'm just putting that sledder into component form. Oh, poops. That's not what I meant to do. Ay, ay, ay. Okay. I'm sorry, everybody. Sorry. Sorry. This guy is my U. That should be 270. So my vector V is 1 times cosine 345, 1 times sine 345. what color do I want to use? Maybe the gray. What's that angle? That's the gravity acting on the individual, which is just pulling them straight down, right? Is that okay, Caitlin? Okay.
So do we not use like 0 and negative 1.5?
Do we not use what now?
0, like, I remember we did like the example of the problem like this in class. You did one of the vectors is like 0 and negative.
Yeah, so that is still happening. So when I simplify this one, that turns into 0, negative 135. I'm just trying to be as specific as I can. So that is exactly what that one turns into. Absolutely. Okay. So if I do u dot v then, so notice when I did that, 0 times anything is just 0, and then negative times negative is positive. Everybody's okay with what I did there? So that gives me about 34.94. Okay. And I know that the magnitude of v squared is just 1. So then my projection of u onto v is going to be 34.94 over 1 times my vector v, which is 0.966 comma 0.259. So that's going to give me 33.75. And the other one gives me 9.04. Yeah. And now I just need to find the magnitude of this. which is 34.94 pounds. Is everybody okay on that? I tried to go through that kind of slowly. How many of you noticed that this number and this number are the same thing? Why is that? This is just as an aside. So we have the projection of u onto v, and that we said was u dot v over magnitude of v squared times v, right? In our case, v is 1, or the magnitude of v is 1, right? Would you agree with that? And if we want to take the magnitude of this, it's the same thing as taking the magnitude of that, right? Well, since u dot v is just a scalar, that can come out. And what did we say the magnitude of v was again? 1. So, as a shortcut, if the magnitude of v is 1, the projection of u onto v is just going to be, or I should say the magnitude of the projection of u onto v is just the dot product of u and v. Which is kind of nice. So conceivably, you could use that shortcut on, what does it look like? Uh, 45, 46, and 47, I think, are all you could use that little shortcut on. I think the rest of them, though, you have to do the full procedure. You guys want to do some more? Yeah, of course. Which one would you like to do? 47. Okay. We can do one of those. Oh, that's not what I want to do. I want to go over here. I have them all written down here. So this one is 47, I think. Yeah. The third story problem. A crate of negligible weight is being pulled up a ramp at an angle of elevation of 38 degrees with a force of 110 pounds. The ramp has an angle of elevation of 25 degrees. What is the amount of force being directed up the ramp? Okay. So the first thing I'm going to do is draw myself a little picture. So here is my ramp with an angle of elevation of 38 degrees. Oh, I'm sorry. that ramp has an angle of elevation of 25 degrees. I just misread the question there. And then sitting on this ramp, we have a crate. And if I draw, let's, okay, so let's just say that my rope is attached to the middle of this crate. So I'll draw like an imaginary X and Y axis here. And then we're pulling here 38 degrees with a force of 120 pounds. Is everybody okay with the picture that I've drawn here? So here's my angle, or my vector u is going to be the green, and my vector v is going to be the red. Because it's asking how much force is being applied onto the ramp, so I want it onto v. Everybody's okay there? Okay. So do I know anything since v is just a ramp, and I've been given a direction here, I can just turn vector v into something with a magnitude of 1, whose direction is, or then resolve it into 1 times cosine 25, 1 times sine 25. And u then, I can do 120 cosine of 38, 120 sine 38. Notice here, because of where I was drawing my ramp, we're pulling up the ramp, so I could draw my ramp in the first quadrant so I didn't have to worry about changing those angle directions into standard forms. Is everybody okay with that idea? Okay. So let's go ahead and then compute these buggers. So 120 cosine 38 is 94.56. And then 120 sine 38 is 73.88. And then cosine of 25 is 0.906. And sine of 25 is 0.427. So then I'm going to do u dot v. So that's 94.56, 73.88 dot 0.906, 0.427. Okay. So this times this gives me 94.56 times 0.906 plus 73.88 times 0.427. When I do that, I get 116.92. And again, since the magnitude of v is 1, I know then the magnitude of my projection from u onto v is the same thing as u dot v, so it's 116.92 pounds. And I think I'm done, right? That's what I read the first time through, wasn't it? So again, I'm only able to say that because the magnitude of v is 1. Should we look at a situation where that decidedly does not happen? Okay. So that would not happen on 8, 9, or 10. Does anybody want to have a preference there on which one we look at? 9 or 10? Does anybody have a preference between 9 and 10? 10? Okay. It says a crate weighing 80 pounds is being pulled up a ramp at an angle of elevation of 29 degrees with a force of 130 pounds, and the ramp has an angle of elevation of 22 pounds. So I'm just going to draw my picture here. Since everything is going up, I can just draw it all in the first quadrant, right? So there is my ramp. Here's my crate. And this guy is 29 degrees. It's being pulled with 130 pounds. And then because my because my crate is at this angle, I should have probably drawn that at the origin. Yeah, let me do that. Sorry. It'll be a little bit more clear what's going on if I do this. So there's my crate. And then this crate is acting downward at with 50 pounds. Sure, I have all these angles right here. I think so. Yeah. So this angle here needs to be 61 degrees, because I know that that normal force that's acting on the crate is going to be perpendicular. So when I look for this angle here, that's going to be 360 minus 61, or 299, I think. All right, so V is 50 times cosine of 299, 50 sine 299, and U is 120 cosine of Oh, shoot. Hold on a second, guys. I got these two angles goofed up again. All right. So this is 120 cosine 29, 120 sine 29. That part's okay. This 61 isn't 61. It's the complement of 22. Sorry. So 90 minus 22 is 68. So this is minus 68. So that's 292. Sorry about that, guys. All right, I think that's good now. Okay, so I turn those both into component forms. And we do u dot v. It's going to be 18.73 times 104.95 plus negative 46.35 times 58.18, which gives us, a moment while I type that in. Negative 731.21. Then I also need the magnitude of v squared. So I get when I do that, I get 2,500. So then my projection of u onto v is equal to negative 731.21 over 2,500 times my vector 18.73 comma negative 46.35. Okay, so I'm going to do this divided by this times that. Negative 5.47, 48, comma, this guy divided by that guy times this fellow. Okay. Gives me 13.56. And then if I want the magnitude of that, this guy squared plus this guy squared, square rooted, gives me 14.62. Is that what I read to you guys? Gosh, I hope not. No, that wasn't at all what I read. Uh-oh, Raggy. That's a lot of stuff to sort through here. Let me look here. It's got to be the picture that's wrong. I mean, the answer is 99 something, so it's not really quite close.
It's closer than like. It's close enough. I got. It's yeah. That was just.
Well, remind me, and we'll go look at this again tomorrow. I'll sit down and think about it this afternoon, and we'll come back to this, and I'll figure out where my mistake was and what the mistake was, and sort that out tomorrow. Because I don't know, I thought I did that right, but it definitely wasn't. So I'll have to look at it and figure out what I did wrong. It was probably somewhere in my picture. But looking through here, I tried to do that slowly enough that I didn't make any mistake. I thought I caught my mistake before I made it when I had that green angle wrong, but apparently there's still something wrong with this. But I'll sort that out tonight and get back to you guys about it tomorrow.